Okay, second type is contingency table analysis, also known as a independent test. Chi-square test for independent. Okay, so this one is involved with two categorical variables, which is we have two traits. For example, is there any relationship between the grade point average of student and their income 10 years after graduation? So if you do the table, so basically the table is GPA, which is start from 1, 2, 3 and 4. Okay, and then income. So level of income. Okay, perhaps we get low, medium or high. Okay, so this one you can see we have two categorical variables, which is grade and also level of significance. Okay, grade point average we will see A, B, C, D. Okay. Okay, so this one we have two traits. So if we need to solve using contingency table analysis. Okay, is there an association between driver of different vehicle class and also their compliance with speed limit? Okay, so if it's involved with two traits, so this one you need to solve using contingency table analysis. Okay, so basically for contingency table analysis is conducted to find the relationship between two variables. Okay, either these two traits is dependent or independent. Okay, for example, if the variable does not affect to each other, so meaning that both trait is independent. Okay, but if the two traits does affect, meaning that the trait is dependent from each other. Okay, so we want to decide if two variables might be related or not. Okay, so that's the reason why we use contingency table analysis. So this one we want to see the relationship between two variables, which is we want to see two variables either have related to each other or not. Okay, information is collected and displayed in a contingency table. So this is we call as a contingency table, which is a type of table in a metric format that shows the frequency distribution of the variable. Okay, so like this. This one is analysis table, contingency table. Okay, so we have two categorical variable, age group of motorcyclists and also safety helmet usage. Okay, so for that, let's see the chi-square test. So actually the formula is same, but the difference is degree of freedom. For contingency analysis, the degree of freedom is R minus 1 times C minus 1. R is number of rows, C is number of columns. Okay, and then FO is observed frequency, and then FES expected frequency. But you need to calculate one by one, which is row total times column total divided by grand total, which is all total, overall total. Okay, let's try example 9.3. A traffic safety engineer wants to investigate if each group of motorcyclists is related to compliance with safety helmet usage. He conducted a study on 200 motorcyclists and obtained the following results. Okay, so grand total is 200 actually. Okay, can it be concluded that each group is related to compliance with safety helmet usage? Okay, so this one you need to see whether they have related or not between age and safety helmet usage. Okay, so first, null hypothesis is there is no relationship between age group and also compliance with safety helmet usage. And then alternative hypothesis is there is a relationship between age group and compliance with safety helmet usage. Okay, so we shall use the significant level which is 0.05. Okay, and then find the critical value. So for critical value R minus 1, which is row minus 1 times column minus 1. Okay, so if you see this table, okay, so this one is row. So we have 2 rows. So row is 2 and then column, okay, in the vertical line, so you have 1, 2, 3, 4. So meaning that here we have 4, row we have 2. Okay, so just substitute 2 minus 1 times 4 minus 1. So we get 3. 3 is degree of freedom. Okay, from the chi-square table, with alpha equals to 0.05 and degree of freedom is 3, the critical value is 7.815. Okay, let's check. So degree of freedom is 3 and then level of significance is 0.05. So our critical value is 7.815. Okay, so then decision rule, if the calculated chi-square is greater than or equal, so means that you need to reject. Okay, first for expected value, so you need to calculate one by one. Okay, so it's different with the goodness of fit test. Okay, so from this side you need to do one by one, which is the formula is row total times column total divided by grand total. Okay, first this one, for example, you don't know this value. Okay, and then you need to find the, this one we call as a row. Total row is 25 plus 33 plus 27 plus 35. So you get 120. Okay, so this one is our total row. Okay, total row for use is 120. Okay, and then total column. Okay, so you need to do one by one for each column. So total column for this one is 25 plus 25. So you get total is 50. Okay, and then you need to calculate total value for total row for did not use. So did not use also same. So 25 plus 27 plus 13 plus 15. Okay, so we get 80. Total grand total is 120 plus 80, so you get 200. So this one is grand total. Okay, now to find the expected frequency from row used and also first column. So you need to row total. Row total for first row is 120 times column total. Column total is 50 divided by 200 grand total. So the answer is 30. So this one is 30. Okay, now for this part, okay, same also. So So total row for did not use is 80. So 80 times total column 50 divided by grand total 200. So you get 20. So for this column you get 20. Okay. Actually you need to check for FE total should be same with the FO. Okay. So if you total up this one, you also get 50. Okay, then for this second column, what you need to do is, so total column for second column is 60. Okay, and then to get the first row and second column, so this one you gonna 30. Total value for first row is 120 times total column is 60 divided by grand total. So you get 36. So this one is 36. Okay, and then for second part, which is second row and second column, so total for second row is 80 times total column is 60 divided by 200, so you get 24. Okay, and then follow the third column and last column. Okay, so for the third column, same also. So this one, total first row is 120 times total column for third column is 40 divided by grand total, so you get 24. Okay, and then for this part, same also. So total row for second column is 80 times total column for third column is 40 divided by 200, so you get 16. Okay, so you need to do one by one. Okay, first you need to find FE. Okay, and then you need to calculate chi-square test. So you need to do one by one for each column and each row. So this one, the formula is FO minus FE divided by FE. Okay, so for this one, 25 minus 30, power of 2 divided by 30. So the probability is 0.833. This one, chi-square value. Okay, and then followed by this one, 25 minus 20, power of 2 divided by 20. So 1.250. Okay, you need to do for each row and each column. After that, total everything. So total for each row, this one you get 0.833 plus 0.250 plus 0.375 plus 0.833, so you get 2.291. Okay, and then for this one, 1.25 plus 0.375 plus 0.563 plus 1.250, so you get 3.438. Okay, and then for chi-square value, we want the total value. Okay, so total value is, we need to add these two parts, so you are going to get 5.729. Okay, so this is your chi-square value. Okay, and then compare with the critical. So since this one is less than the critical, so we do not reject null hypothesis. So we accept alternative hypothesis, which said that there is no relationship between age group and compliance. Okay, so meaning that if there is no relationship, means that these two categorical variable is independent. Okay, because there is no relationship, meaning that it is independent. So it's with the name, which is contingency table analysis or chi-square test for independent.